Hello dear friends, all the FI BTech student from the E&TC department. Today we have introduced with the very important topic related to our subject basic electrical engineering and digital electronics. So it is related to the unit 4, that is nothing but logic gates, prepared by Professor Dr. Bhushan V. Patil. Please share and accept the link related to the official E&TC department YouTube channel. It is having number of videos related to your curriculum. So click on bell icon, subscribe and like the channel. We start with our department vision and mission. So vision of the department to produce the competent electronics and telecommunication engineers with a commitment to serve the society. Mission of the department, deliver to innovate, ICT enable and interactive learning, fostering excellence in electronics and telecommunication engineering. Cultivate scientific inquiry, ethical responsibility and collaboration to address social and technological challenges effectively. Empower diverse students with the skill for employment, entrepreneurship and research, nurturing professionalism and lifelong learning. Program specific outcomes. PSO1 for engineering fundamental and problem solving. Apply core principle of electronics and telecommunication engineering, including devices, circuits, signal processing, communication systems, and embedded platform to analyze and solve real-world engineering problem. PSO2 is related to digital software and embedded competency. Design, simulate, and implement electronics and telecommunication solution using modern software tool, programming environments, and embedded platform for industry-related application. So this is all about the mission and vision of the department. Now we start with our unit 4, that is nothing but logic gate. The outline of presentation is logic gates, basic gates, it containing AND, OR and NOT gate, universal gates, NAND and NOR gate, then special type of gates, XOR and XNOR. Now in digital electronics represent the information 0 and 1 with only two discrete value. Ideally no voltage, for example 0 volt represented as 0, and full source voltage, for example 5 volt represents as a 1. Realistically low voltage, for example it is less than 1 volt, represent as 0, and high voltage is greater than 4 volt, represent as a 1. We achieve this discrete value by using the switches. We use transistor switches which operates at a high speed electronically, a small in size. Here we can see the analog versus digital signal. So analog system process time varying signal that can take on any value across a continuous range of voltage in electrical and electronic system. Digital system process time varying signal that can take on only one of the two discrete value of the voltages in electrical and electronic system. So these discrete value are called as 1 and 0, on and off, high and low, or true and false, etc. So as per the scenario, digital signal is in terms of 0 and 1, and the analog signal is continuous sinusoidal signal. Here we can getting the one information related to the logic gates. So basically the most basic digital device are called as gates. Gates got their name from their function of allowing or blocking of gating the flow of digital information. And therefore gate has one or more inputs and produces the output depending on the inputs. So gate is also called as a combinational circuit. So basically there are three important gates are there, AND, OR and NOT. So binary system, it containing 0 and 1, or it is having the value of low and high. So these are the two discrete values, and basic building blocks of that logic gates is AND, OR and NOT. These are the basic gates. So first of all we have to define what is the logic gates. So gate is a device that perform a basic operation on electrical signal, and circuit gate combines to perform more complicated tasks. So logic gates containing the three convention, that is nothing but Boolean expression, logic diagram and truth table. So how to describe the behavior of gates and circuits? So it is in terms of these three parameters. So Boolean expression is nothing but uses Boolean algebra, a mathematical notation for expressing two value logics. Then logic diagram, it is a graphical representation of the circuit. Each gate has its own symbol. And also truth tables, a table showing all the possible inputs values and the associated output values with the inputs. So this is the representation of logic gates. So we first convention related to the logic gates, that is nothing but basic gates. It contains AND, OR and NOT gate. Then we have to study the universal gate. It contains NAND and NOR. And lastly, we can see the special type of gates. It contains the XOR and XNOR gate. So AND function, it is a logically, it is a multiplication. So output of Y is true if the input A and B are true, else it is false. So as per the symbol, we can see the symbol of AND function. So as per the scenario, the AND function is nothing but logically multiplication. So in truth table, there are two inputs A and B. So whatever the output depends on that logical multiplication. So value A is 0, B is also 0. So A and B having the value is 0. Similarly, if A is 0 and B is 1, then value is 0. 0 into 1, 0. Similarly, input A is 1 and B is 0. So A into 0 is again 0. And A is 1 and B is 1. Then and then we can get the value is 1. As per the scenario, AND is a logical multiplication. So Boolean expression can be represented like that. Y is the output is equal to A cross B or A dot B, or simply we can say that A into B. So for that AND function, generally we have to use the 7408 IC. The pin configuration of that IC as shown in the diagram, there are 14 pins are there, 1, 2, 3, 4, 5, 6, 7 at the left side and 8 to 14 are at right side. Pin number 7 is always ground and pin number 14 is always VCC. So here in that pin configuration of IC 7408, that is for AND gate, there are 4 gates in that IC. So as per the requirement, we can use any one or all our 4 gates for our applications. So OR function is, we can see here. So in that, the logically OR is nothing but addition. So as per the convention, if there are two inputs A and B, the output Y is nothing but we can consider from the addition of A and B. If A value is 0, B value is 0, so 0 plus 0, it again gets 0. But in between A and B, any one value is 1, the output value Y becomes 1. So this is the scenario for OR function. Boolean expression for the OR function, Y is equal to A plus B. And basically for the OR function, generally we use the IC 7432. It is also having the 14 pin IC, and as per the scenario, pin number 7 is ground and pin number 14 is always VCC. So 7432 having 14 pin IC, it contains the 4 OR gate. So as per requirement, we can use any of 4 gate. We can see that. So also OR function is logically addition. So as per the analogy, we can see that S1 and S2 are the parallel switches. So from that, if either or both the two separate switches S1 or S2 are closed, the lamp will be on. Only when both S1 and S2 are off, the lamp will be off. So as per the condition, if S1 and S2 are open circuited in first case, that time lamp is off. But in that case, in second case, any one value is closed or any one value is high, that time lamp will be on. So this is the analogy for OR function. Convention of NOT function. So NOT is nothing but complement. So here only one input is there and only one output is there. So for that purpose, so input is 0, output is 1, and input is 1, output is 0. So symbolically, or Boolean expression of that NOT function is Y is equal to A bar. So that bar denotes the complement or negation. So for NOT gate, we use the 7404 IC. It is also having the 14 pin IC. Pin number 7 is always ground and pin number 14 is always VCC. So these are all are the basic gates for the digital electronics or logic gates. So NOT gate having simple input, output is NOT gate or inverse of its input. So this is all about your gate. So this is all about the scenario. Next gate is your NAND gate. NAND is nothing but combination of NOT and AND. So having the description is like that. So symbolically NAND is nothing but combination of NOT plus AND. So output of AND gate is low or logic 0 only when both the inputs are 1, otherwise its output is 1. So logically the truth table for that NAND gate function is nothing but NOT AND. So bubble, it symbolically it can be denoted by AND with bubble. Bubble is an inverter. This is an AND gate with an inverted output. So basically the output will be like that. It is exactly opposite to the AND gate, means any one input is 1, the output will be 1. So in that truth table, A and B value is 0, output is 1. If A is 0 and B is 1, the output is 1. So in that case, the universal gate, why we call it universal gate? Because any of basic gate and or any basic gate or NOT gate can be constructed from that NAND function, or any combination of the basic gates, we can form the any type of gate or any type of logical function. So Boolean expression for that NAND function is y equal to a cross b bar or a dot b bar. The symbolically represented, it is a combination of and NOT. So NAND and NOR are the universal gate, because with the help of these gates we can implement all the gates, and also we realize any Boolean expression with the same. So output of AND gate is low or logic 0 only when it's both the inputs are 1, otherwise its output is 1. And for that purpose, in logic gates generally we use the 7400 IC. It is also having 14 pin IC. As per the scenario shown in the figure, pin number 7 is always ground, pin number 14 is always VCC. And as per that scenario, there are 4 NAND gates in that 7400 IC. So logical equivalence of NAND gate gives the same result as the AND gate feeding to an NOT gate. So this is the symbolically convention of NAND gate as gate. Next is your NOR gate. NOR gate is also having NOT OR. Basically it is a convention of NOT OR. So NOT OR means obviously it is exactly opposite to the OR gate. So in OR gate is having the addition, means any one value is 1, the output is 1. But in NOT OR means NOR function, any one value is 1, the output will be 0. So as per the truth table we can see the output of NOR gate is low, logic low or logic 0 only when both the inputs are 0, otherwise its output is 1. So it is also having the NOR gate is also having universal gate, because we can construct any basic gate and or inverter or any combination of this function, we can form the NOR gate. And symbolically and Boolean expression of that NOR gate is y is equal to a plus b bar. So NOR gate output is low or logic 0 only when both the inputs are 0, otherwise its output is 1. And for that purpose in logic gates generally we use the 7402 IC for the NOR gate. It is also having the 14 pin IC. Pin number 7 is always ground, pin number 14 is always VCC. So symbolically we can equivalent circuit of NOR function or NOR gate is in terms of NOR plus negation or NOR gate. So it is also having the same function. So NOR gate similar to NAND gate, NOR gate is also universal gate. NOR gate can be used to construct the AND gate, OR gate or inverter or any combination of these functions. So logic operation of NOR gate is low, output occurs when any of the input is high, only when all the inputs are low. So this is all about the analogy. Then others, next is nothing but special type of gates. It contain XOR or XOR, EXOR. So XOR gate is nothing but exclusive OR gate. It is a circuit which will use the true output if either but not both of its two input are true. So symbolically it can be represented like that. So N circle plus sign is used to show the XOR operation, and XOR operation is nothing but the output of XOR gate is low or logic 0 only when its both input are same, otherwise its output is 1. So these are the logically convention, means both the value are same, then and then the output will be 1. So this is all OR gate. So what is the difference between XOR gate and XNOR gate? We can see here. So difference between XOR gate and OR gate, they differ only in one input situation. When both the input signal are 1, OR gate produces 1 but XOR produces 0. XOR is called as OR gate. Similarly in the truth table about the analogy, then next is your XNOR or EXNOR. XNOR gate, the output of XNOR gate is low or logic 0 only when both the input are different, otherwise its output is 1. So XNOR is exclusive NOR gate. Circuit does not have opposite to the XOR gate. It will use false output if either both not or but not both of its two input are true. The symbolically XOR gate with all with a small circle on the output. The small circle represent the inversion. So basically the logically the convention of or truth table related to the XNOR gate as shown in the figure. So this is all about your XNOR. It is also the special required the 74266 IC. It is also 14 pin IC. The symbol of that XNOR gate as shown in the figure with the truth table. So this is all about your XNOR gate or EXNOR gate function. So this is a summary of all the symbol of logic gates and OR, NAND, NOR, NOT, XOR and XNOR. So this is related to the all about the information related to the logic gates. Thank you very much.